I'm going to talk about and go into maybe a very short deep dive on config management just because of the time we have today. But config management is basically a way for us to centralize all of the configuration files and SCM-based infrastructure in code, keep it all inside of a central repository where everyone can manage and bring in branches and merge stuff into one centralized place. This is great for not having to worry about individual snowflakes or individual configuration changes on VMs or infrastructure that one infrastructure guy went in and made changes to, and nobody knows about it. It was never documented anywhere, right? So keeping it all in code, infrastructure as code, makes it a lot easier to manage and work towards. Today, I'm just going to go over very briefly about Nomos. Nomos is a binary that comes from Google that is basically a way for you to easily validate your repository to see if your configuration for config management is correct, like you're putting things in the right directories and your YAML files are syntaxed correctly. There's also, a little bit of code review. I'm going to show you a demo. And this is all being done in the GKE On-Prem cluster that we all share on Packet right now as well. So while it is being done on GKE On-Prem, everything relates to or can be done on GCP as well. Okay, it doesn't matter what platform you're on. It's going to work on either or. Here, let's get into the demo right now. So over here, I just have a terminal open, and I'm going to create a simple directory and show you the Nomos command. Hopefully you guys can see that on the left here. The Nomos binary that comes from Google, again, it lets you validate your repository. It also lets you initialize your repository for config management. And you'll see something like this sort of structure where you've got a cluster directory, cluster registry directory, namespaces, system. And in here, it just gives you a simple repo.yaml file, which is the basic file that comes with every Anthos Config Management repo that dictates this is a repo dedicated for config management. Okay, so I have this code already done in Visual Studio here, and in my example, I'm doing a Nomos vet just to vet that my repo here is correct, everything's set up correctly, and it's going to return a no output there, but it's an exit 0 status. So that means everything's good. If you saw some issues there, you would have saw an output of errors, okay? But everything's good there. And basically in my repo, I've got a few resources in the cluster registry portion where I'm telling it, here's my cluster, specifically my user cluster that I named Chris. And I'm telling it, okay, I want to apply my specific machine deployment config and only apply it to my specific user cluster. Okay, so I've got a selector in place here to say, apply this machine deployment config and only apply it to mine because I don't want to affect everybody else's demo for today, right? I only want to apply it to my own demo. My machine deployment is basically a specification of what I want in the cluster physically, like what kind of nodes, how much CPU, how much memory, replicas, etc. Okay, so you can define all of that inside of a machine deployment config, which is what you see here. And I'm also defining the default namespace. Okay, and that's the repo file. And then I'm going to go into back to my. This is where the repo is being hosted. Actually, it's on GitHub, and so this is publicly available right now. And I'm going to be updating this code. And when I update it, you'll see that when I make changes to the repo, the cluster is going to pull that information from my GitHub repo and automatically update it on the fly. It's going to be polling the repo maybe every 15 seconds. So you'll see that change happen almost instantaneously. Okay, so on the left here, I'm doing a watch kubectl get nodes, which is just telling me here are your worker nodes for your user cluster specifically. Okay, I've only got 3 right now, and they've been living for 40 minutes. On the right here, I just opened up a config management operator file. This is where I'm going to define the config management operator to say, okay, please pull from my repo, the GitHub repo that's public right now. And it's going to pull from the master branch, okay, because that's the only branch I have right now. It's just master, and I want it to pull from master only. And I'm just using no secret because I didn't want to make this overly complicated. I don't need SSH keys. It's a public repo. Anyone can pull from it. Okay, there's no secrets to hide in there. So once I have that all written out, I'm going to apply that config on the right. And I can do that with a kubectl apply with the file name. And once that's done, it'll take a few minutes to get the nodes to update. But basically, I'll show you what the changes actually happen. Right now, the nodes are set up exactly the same way as is defined in the repository on GitHub. So no changes are going to happen right now, but that connection is happening right now. That link to the repo is happening. It's already connected because I just applied it. But once we make the change in Visual Studio and push it to our repo, then you'll start seeing the change. Okay. Right now, I'm going to look at the config management pods that were just spun up. And inside of this Git importer, you'll find two containers. There's the Git sync and the importer containers that are basically what's handling that pull from the repo and scheduling when it gets pulled and when it gets synced to the GKE On-Prem cluster, specifically my user cluster. And so you'll see that on the right here. We've got some messages in our logs, but let's look at the Git sync. And you'll see at the bottom here, no update required because there's no changes yet. Nothing's been changed in my repo. I'm going to go through and go back to my Visual Studio Code. I'm going to create a new branch. I'm going to name it Scale Up, I believe I called it. And basically, this is how you would want to do it as a developer, right? You're not going to just commit to master and constantly commit to master. That's kind of an annoying way to work with Git, especially if you're working in a team and everyone's trying to work on the same project, and trying to merge to master all the time is going to be annoying. You want to make a separate branch and then merge it when you do a pull request. Okay, so I created a new branch. I'm changing the CPUs, the number of CPUs I want to 4 gigs of memory, and I'm also going to increase the replica count from 3 nodes, 3 VMs to 5. Okay, and once I push those changes to the repo, I'm going to merge that with master. Okay, so you see I've made those changes. I'm just doing a git diff on there. I'm going to apply that. And it's not going to apply to the cluster right away, right? I'm just pushing to a separate branch. But if you recall from the previous example, I was saying pull from master. Pull from my repo, but only specify master. But in this case, I'm pushing to a separate branch, so nothing's going to happen to the cluster just yet. Once admin guy goes in and approves your changes and wants to merge it, he gets to decide, okay, we're merging this with master, and we're okay to scale up this cluster. So I'm doing that myself here. Normally, you don't want to create your own pull request and then merge it yourself. You should have someone else review it. But for demos purposes, might as well do it by myself. So I'm going to create a pull request, and I'm going to merge it myself. And I'm going to confirm that. I'm just going to delete the old branch because they don't need it anymore. And now that's going to be merged with master. So now that it's merged with master, we're ready to start, or ready. That's already live code that's living in the master branch. The repo on the cluster side is going to see that change, and you'll see that when I post the logs here. It'll see that there's some changes happening in the repo, and it's going to pull that to the local cluster on GKE On-Prem and update the actual nodes that we have running or watching here. So these nodes are going to start upgrading, rather. They're going to go from 3 replicas to 5. And we're going to scale up from 2 CPUs to 4, up to 4 gigs, and so on. This part takes a little bit of time. I'm going to just fast forward a bit. And you'll see in my machine deployment, it's got the updated CPUs and memory and replicas on the cluster itself. And after a few minutes, you'll start to see the nodes on the left spin up. Okay, so now we've got 5 nodes. 2 of them have just come up within a few seconds. The others have a few more minutes to go. But during recording last night, I realized I have only specified about 5 IPs and 5 nodes that I'm allowed to use with this cluster. And so I'm going to run into an issue here where I can't spin up another node and try to bring up the correct specs for that node without running out of IPs. So in order to solve for that, I decided, oh, there's an issue with my code, and I'm going to fix that by reverting the changes. So the same way you would revert changes with any other application with code, you would just go into Git and do a rollback, or rather do a revert. So I'm going to do that in Git. I'm going to say, check out the master, let's look at the logs, and that merge, let's take the commit hash from there, copy that, and I'm going to do a Git revert on that hash. And since this is a merge with master, we have to specify -m1 here, and we have to force it as well. This is going to fail because the repo on the remote side has more commits than your repo on the local side. It looks like you're missing something. And so we've got to say, no, this is on purpose because we're reverting it. So we're going to force this push. And then once we get that change, you'll notice the change on the GKE On-Prem cluster, and it's going to go back down to 3 nodes again, back down to 2 cores and 2 gigabytes. Okay. So now we've got 5 nodes right now, and it's going to start to scale down. You'll see that nodes are starting to disable scheduling, so you can no longer use these nodes, and they're eventually going to be spun down. And after a few seconds, you see, okay, we're down to 3 nodes now, to what we originally have at the beginning of the demo. One thing to keep in mind that was just a machine deployment example. We've modified a machine deployment config and demoed how that changes things when we're updating a repo. But you can manage other Kubernetes resources as well. If you want to manage your role bindings, for example, or other Kubernetes resources, you can do that in config management. This is just one simple demo using machine deployments specifically. That's pretty much it for my demo. And if you want any more information on this topic specifically, there's a few links here.